Hello guys, welcome to Machine Learning Mindset. So in this video, I'm going to walk through the linear regression approach. I will explain to you what it is in a high level sense. So the linear regression is an approach in statistics and machine learning which aims to find the relationship between a dependent variable and one or more independent or explanatory variables. So what is a simple linear regression? In case we're calling it a simple linear regression, we only have one explanatory variable. So as you can see here, we have y equals to fx, which is as a function of x, and this function is supposed to be linear based on the definition of the linear regression. So in case we have multiple linear regressions, so we have more than one explanatory variable. It means you have x1, x2, up to xn, and y is a function of these independent variables, and the function and the dependency is of course linear. And last term is multivariate linear regression. This is different. In this case, we have multiple correlated dependent variables that we are supposed to predict. So in case, let's go back. So in case we have here f of x1, x2 to xn, on the left hand side we have multiple y's like y1, y2, y3, and each of which are corresponding to one function of other independent variables. So in this case we call it multivariate linear regression. You shouldn't confuse multiple linear regression with multivariate linear regression. So just be careful about that. So we have the example of simple linear regressions. As you can see, we have y here and x here. Let's go ahead. We have a couple of data here. Any of these data points has x and y. So the x is the independent variables and y is dependent on x. So let's assume we want to map a function, a linear function that try to estimate the data. So, and the function should be linear. Let's say this is our function ax plus b, which is a linear function, and we didn't say y here because this is y hat. Basically this function gives us as an estimate of y, not the y itself. So when we try to map the data on a linear function, so we need to implement a couple of approaches to estimate. So for estimate this thing, we of course need to estimate the error. What is the error? Assuming we have one x here, one particular x, and the associated dependent scalar response is y. So we have a pair of x and y, this point, and our estimate is y hat based on this linear function that we try to map the data. And here the error is basically the difference between y and the estimate. So there are different ways to report this error. Sometimes we report based on y minus y hat and the absolute value, which is the mean absolute error. Or sometimes we report it as the square of the difference between y minus y hat, which is called mean square error. The reason it's called mean because for each of these points, we calculate this error and take the mean over all the samples. So this is the overall error of this linear regression model. To do that, basically there are different methods for doing so, like the least square error, gradient descent. There are many different methods to optimize this. This is basically an optimization function because we want to find a line which has the least overall mean error. So how do we do it? In the next videos, I'm going to explain with codes that what method we're using and how we do this optimization. So we basically use gradient descent. We're not going to go through all the other methods, so I should give you some links for your reference. Feel free to read them to explore more about this method. But what we do it, as I mentioned, we do it with gradient descent using TensorFlow and Keras, and we'll show you in the coming videos. So thanks for watching. Feel free to share your comments and questions if you have any ideas, so we can improve the content. Thank you so much for watching.